As I'm up for 1 2 hours, so I can do the complete paper with all the uh, description, etc. Everything, जो भी explanation, questions आपके ठीक है. So I'll be up for 2 3 hours. I don't have anything in the morning, so I can stay up. अच्छा we're good to go. We all. I'm up for 1 2 hours. One second, इसकी आवाज बंद कर दें. अब हम यहीं पे रहते हैं. वापस आ जाते हैं ATP के ऊपर. ठीक है. Now let's begin. The first thing is, so it's a 1 hour question, a 1 hour paper, so you have to be very quick with it. Not much time here to waste. So starting with the first question, and it's electrolysis. Remember ATP के अंदर you ज़्यादातर जो question आएंगे, uh, most of the questions, they would be. अच्छा ठीक है. I'm going to reach that part as well. But quickly first, electrolysis. बल्कि इस question के बाद ना, I'm going to do the moles. I'm going to tackle the moles question then, ठीक है? And we might do the moles question a bit more. अच्छा एक second है ना, let me. चल ठीक है. अच्छा, this one. A student is doing electrolysis. This is an electrolysis question, and you have cathode and you have your anode. Uh, One second. So you have your cathode and you have your anode, and you have to complete the table. So quickly, the first one is given, and you're being asked to tell the observation. Now, this electrolysis has already been done. So the part that you need to figure out is in the first row is what is the observation if copper is formed. So what's the observation? It's a pink metal. So pink metallic. So you're going to get a pink metallic deposit. That's the first thing. दूसरे पे आ जाते हैं. It's potassium iodide, aqueous. Aqueous means के there's water in it. So potassium iodide. How many ions do we have in potassium iodide? Potassium iodide is K+1 and I-1. These are the two ions in aqueous potassium iodide. The negative cathode is going to attract the positive ion. The negative ion would be attracted to the positive, and there would be two more ions because this thing is aqueous. Okay, so whenever something is aqueous, there would be two more ions. One would be H+1, and the other one would be OH-1. Now, anything that approaches cathode, anything that comes over here is the one negative cathode ke upar. It's the one that's going to gain electrons. So battery is sending in these electrons. Okay, if you go down, the negative terminal of the battery is sending all these electrons. Now, either of these two is going to gain electrons. So, iske andar na, how do you figure out which one gains electrons? The one that's lower in the reactivity series. So you have, let me add a few more people. So you have all these, you have this reactive series, which is KNaCl. K is right at the top. And if you remember the reactive series, ke bottom pe jaake na, there's H. Somewhere at the bottom there's H. So the one that's lower down in the reactive series, that's the one that always ends up gaining electrons. So battery ने electrons send किए, और यहाँ पे किसने electron gain किए? इन दोनों में से ना कोई एक है. Somebody has a higher tendency to gain electron, and that's the H ion. And H is diatomic, so it's going to be 2H+1. उसको double करना पड़ेगा, and they're going to gain 2 electrons to form 2 hydrogen atoms, which are going to get together to form an H2 gas molecule. ठीक है? So that's what's happening at cathode. So H2 gas formed. उसका नाम लिखना होगा क्योंकि उसने he's written the names of the things, so you have to write hydrogen gas over here. And what is the observation? Whenever hydrogen gas is a colorless gas, so it's going to be bubbles or effervescence that are going to be seen at cathode. So यहाँ पे ना आपको छोटे-छोटे bubbles मिलना शुरू हो जाएंगे. On the other side, what's going on the other side? Anode ke upar, the battery is the one that's going to be gaining electrons. So it's going to be pulling electrons or removing electrons from either of the two ions, OH-1 or I-1. So यहाँ पे भी एक series है which has to be remembered. उसके bottom के ऊपर it's I-1, then Br-1, then it's OH-1, and then it's Cl-1, and then you have tons of other ions which we don't really care. So your ions, you have two options. It's either OH or it's I minus one. So the one that's at the bottom, that's the one that has the stronger tendency to lose electrons. So it's going to be I minus one, that would be losing electrons. And again, it's also group 7 is diatomic. Pura ka pura group 7, that's diatomic. So it's going to be 2I minus 1, which would end up losing electrons to form. Uh, so it's going to lose 2 electrons. And as a result, it's going to form 2 iodine atoms, which would join together to form I2. So वो जो brown, sorry, yes. So the brown liquid that's being formed, just wait 1 second, is it being shared? नहीं, एक second, शेयरिंग बंद हो गई है. अच्छा, so coming back, the brown liquid that's being formed is iodine. Let me open the chart. अच्छा, make sure you keep commenting in the chat. ठीक है, I can't actually open the chart right now. अच्छा, so this is this part. Then you have dilute sulfuric acid that's being electrolyzed. So I'm going to remove all of this now. You have dilute sulfuric acid that's being electrolyzed. So dilute sulfuric acid में I'm going to use a different colored pen for that. Pink के अंदर कर लेते हैं, ठीक है? अच्छा, so in pink, dilute sulfuric acid. The sulfuric acid में there are two ions, H plus 1 and SO4 2 minus. ये दोनों आयंस मिलकर ना सल्फ्यूरिक एसिड बनाते हैं, लेकिन वो ऑब्वियसली डाइल्यूट है. डाइल्यूट का मतलब है there's water as well, so there's H plus 1 and OH minus 1 as well. इस साइड पे बैटरी इलेक्ट्रॉन्स भेज रही है, इन दोनों में से कोई इलेक्ट्रॉन गेन करेगा. दोनों, both of them are the same thing. तो इक्वेशन तो यही बनेगी 2H plus 1 प्लस, मतलब वो H plus 1 ही इलेक्ट्रॉन गेन करेगा और तो कोई है नहीं वहां पे. तो यहाँ पे तो हाइड्रोजन गैस बनेगा और नीचे उसने लिखा हुआ है बबल्स ऑफ कलरलेस गैस. दूसरी साइड पे क्या होगा? दूसरी साइड पे OH minus 1 or SO4 2 minus. Someone out of these two is someone out of these two. Just 1 second. Let me add people. Acha, so someone out of these two is going to the pink ones, SO4 minus 2 and OH minus 1. Someone out of these two is going to lose electrons. तो उसमें series में देखो तो ये SO4 minus 2 तो बहुत ऊपर आता है. That's not going to be the one. It's going to be OH minus 1 that would end up losing electrons. और उसकी इक्वेशन क्या होती है? उसकी इक्वेशन, you have to remember the equation for OH minus 1 losing electrons. It's always, this equation has to be remembered. ठीक है, it's 4OH minus 1. It loses electrons, loses 4 electrons, and ends up being decomposed to form 2 water molecules and an oxygen molecule. So this thing is produced and oxygen gas is given off. So you get oxygen gas as a result. Okay, so you get oxygen gas as a result. So that's the first part. And then let's move to the next part. Give a test and observation to identify oxygen gas. Remember, okay, you must have the test for ions, cations, anions, etc. Test of gases. Oxygen gas का test क्या होता है? कि it's you add a glowing splint. ठीक है, not a lighted splint, a glowing splint. And when you add this glowing splint, what happens? It relights. In the presence of oxygen gas, it relights. So that is what's going to happen. That's the test for oxygen gas. Remember your test, that's very important for ATP क्योंकि पूरा का पूरा एक क्वेश्चन ही उसी के ऊपर आएगा, ठीक है? उसमें बस वो टेस्ट के रट्टे लगने चाहिए अच्छे तरीके से. अच्छा, anyways, the next part is that you have, the next part is you have, अच्छा मैं लास्ट वाला मैं रिपीट कर देता हूँ. Hold on 1 second. ठीक है, just 1 second. अच्छा, the last part is कि मैं सल्फ्यूरिक एसिड का रिपीट करूं. सल्फ्यूरिक एसिड में ये पिंक में किया हुआ है सल्फ्यूरिक एसिड. अच्छा, this paper is winter 19 question paper 4-1 actually. तो winter 19 October November 19, ठीक है, May June 20 में तो पेपर ही नहीं हुआ, तो that's the last one that was there. अच्छा सल्फ्यूरिक एसिड H plus 1 आयंस है और SO4 minus 2 आयंस है और दो आयंस H plus 1 and OH आयंस पानी से आ गए हैं ठीक है uh, so so these are the ions and I said just 1 second let me I said use the chat हाँ ठीक है 42 41 में कोई ज्यादा फर्क नहीं है तो मैं उसका इतना बड़ा डिफरेंस नहीं है ठीक है सो यू कैन इग्नोर दैट फॉर नाउ अच्छा ये अली सल्फ्यूरिक एसिड H plus 1 ions and SO4 minus 2 ions and H plus 1 and OH ions coming from water as well. तो कैथोड के ऊपर इनमें से कोई इलेक्ट्रॉन गेन करेगा तो वो इलेक्ट्रॉन गेन कौन करेगा H plus 1 के अलावा कोई है ही नहीं यहाँ पे तो वही गेन करेगा तो इट्स गोइंग टू फॉर्म हाइड्रोजन गैस और इन दोनों में से someone is going to lose electrons either OH minus 1 or SO4 minus 2 तो वो जो सीरीज एनोड वाली सीरीज है वो याद रखनी है I minus 1 Br minus 1 OH minus 1 और फिर वो पूरी बाकी आयंस आ जाते हैं तो OH minus 1 bottom पे it has a stronger tendency to it has a much stronger tendency to lose electrons so for OH minus 1 because it has a stronger tendency to lose electrons तो उसकी equation ये होती है you have to remember this equation it's 4OH minus 1 losing electrons 4 electrons to form oxygen and water molecules so oxygen gas is produced at this side at anode क्योंकि OH ions जो है ना they are the ones that are going to get discharged. अच्छा, anyways, we're going to move to the next part, which is that calcium carbonate. You have calcium carbonate, and this calcium carbonate reacts with dilute hydrochloric acid. Student investigates the rate of the reaction at three different temperatures. As a rate of reaction is being investigated at three different temperatures using the apparatus shown. So calcium carbonate or hydrochloric acid, what is the reaction? Remember your reactions as well. When you have calcium carbonate and you have sulfuric acid, so I'm going to just 1 second, let me type the year of the paper. It's 9701. Question paper, winter 19, question paper 42, 41 actually. 41. अच्छा, anyways, और एक सेकेंड ये मैं किसी तरह रब कर दूं हाँ ठीक है now it's gone now coming back equation उससे दी हुई है ठीक है the reaction has already given you the equation it's calcium carbonate reacting with HCl to produce a salt water molecule and a carbon dioxide molecule तो जो carbon dioxide gas produce हो रही है ना he's trying to measure that carbon dioxide gas शुरू में बड़ी तेजी से produce होती है every reaction is fast at the beginning ठीक है it's faster at the beginning तो ये piston जो है ना it would start to move backwards ठीक है and then the reaction eventually slows down. Anyways, in each experiment, the student adds dilute hydrochloric acid to an excess of calcium carbonate. The volume of carbon dioxide in B is recorded every 30 seconds. So, शुरू में ज़्यादा बन रहा होगा फिर एकदम से reaction खत्म होना शुरू हो जाएगा. It would slow down and there would be less and less carbon dioxide that is going to be produced. So, what is meant by an excess of calcium carbonate? It simply means more than the required amount. It basically means that if calcium carbonate and hydrochloric acid are reacting to hydrochloric acid, you're going to run out of hydrochloric acid, but N minor calcium carbonate would still be remaining at the end, more than the required amount. Next is name two pieces of apparatus A and B. A is your conical flask. That's obviously your conical flask. Take a simple apparatus. And B, what is B? B is your measuring gas syringe. Or simply gas syringe. Anyways, name two. We're done with that. Name two pieces of. I've already typed. It's winter 19 question paper 4-1. Now part C is the student does the experiment one at 20 degrees centigrade. Name a piece of apparatus that can be used to keep the temperature constant. Now he's doing the experiment at 20 degrees centigrade and a piece of apparatus that can be, you have to keep the temperature constant. So how can you keep the temperature constant at 20 degrees centigrade? Uh, so heat, what you have to do is not 9701E, that's A levels. I was previously doing that paper. It's 5070. As a name of so it's this one over here, the 5070. Let me 1 second. So it says 5070, your O levels ATP paper. As a piece of apparatus. So it's going to be you can put a heat proof jacket on it to ensure that the temperature uh, remains constant. So there's no heat loss. Uh, so that could be done. A jacket could be on top of the flask so that no heat loss occurs. Then the student does two more experiments. Experiment 2 at 40 degrees centigrade, experiment 3 at 60 degrees centigrade. Suggest two variables that the student keeps constant so that temperature is the only variable that affects the rate of the reaction. As a water bath is possible. Uh, you get this question over here. You get 20 degrees centigrade water bath जो है ना, water bath heating के लिए use होता है usually, which you're going to use in this case because you have to take the temperature at 40 and as well as 60. Question जो था ना वो actually था कि now you would have to consult the market scheme. ठीक है, मैं end में जाके I'll open the market scheme and I'm going to check this as well. Because at my point, I think the question is basically asking how could you keep the temperature constant, and that is you have to stop it from losing or gaining heat. You have to make it constant. So वो जिस तरह thermos या flask के अंदर ना there's a so you need some heat proofing material so that no heat is lost. But we can check that. Water bath जो होता है ना that's for raising or decreasing. मतलब 40 degree centigrade पे लेके जाना है. So you use a water bath. 60 degree centigrade पे you use a water bath. So but how do you keep the temperature constant? So we're going to check that answer later on in the market scheme. Okay, so that was by doubt, so we can check that later on. I just suggest two variables that a student keeps constant. So that means when you're doing an experiment, you have to keep everything. Only the variable that you're investigating has to change. Everything else has to be kept constant. The rate of reaction, चार पांच factors से rate of reaction can remember चार पांच factors होते हैं. One is temperature. He's already investigating temperature. The other factors, as somebody has already mentioned, is concentration. So the concentration of hydrochloric acid has to be kept constant. Calcium carbonate, the pieces, the size of the pieces, that is going to affect the rate of reaction. So that needs to be kept constant. Okay. The other one is catalyst तो है ही नहीं इसमें. तो बाकी factors जो है pressure जो होती है वो भी affect नहीं करेगा क्योंकि pressure gases को affect करता है. So hydrochloric acid and calcium carbonate are not going to be affected by pressure. So it's going to be concentration and surface area as somebody mentioned in the messages. So that is correct. यहाँ पे add भी कर लेते हैं. It's going to be concentration of, remember exactly बता दो concentration of HCl. ठीक है. चलो ठीक है. Then that's my mistake क्योंकि I thought he was talking about maintaining or controlling the heat loss. ठीक है. So water bath is going to be correct. ठीक है. वो मेरी mistake है. As a concentration of HCl and surface area जो है ना वो भी आप exactly mention करो कि surface area किस चीज का, surface area of या फिर वो size of particles of calcium carbonate. The next part is the student plots a graph of the results. So the graph is given and volume of carbon dioxide. Describe how the graphs are used to decide which experiment has the fastest rate. The steepest gradient जो होता है that's the fastest. ठीक है. The highest gradient जिसका होता है the steepest that is always the fastest. तो describe how the graph है तो वो 1 मार्क का क्वेश्चन है. उसके अंदर आप बता दो कि जी how the graphs are used to decide. So more gradient or steeper gradient, that indicates faster reaction. The other one is write a number in each of the boxes on the graph to identify experiments 1, 2 and 3. तो ये आसान है कि ज़्यादा टेम्परेचर होगा तो फास्टर होगा, कम टेम्परेचर होगा तो it's going to be slow. Or 40 degrees centigrade, so ये जो 20 वाला होगा ना, that's going to be the slowest. Next part is state how the graph show that the reactions stop. Because the reactions stop, why? Because the line becomes flat. As you can see over here, if the line becomes flat, that means vertical axis पे movement नहीं हो रही, which means the volume of carbon dioxide has stopped forming. No more volume of carbon dioxide. So the line becomes completely flat, or the gradient becomes zero eventually. So state how the graph show that the reaction stops. Gradient becomes equal to अच्छा एक्सपेरिमेंट नहीं सॉरी एक्सपेरिमेंट नंबर्स ही लिखने थे मैंने वो टेम्परेचर के हिसाब से लिख दिए जस्ट 1 सेकेंड मैंने बस वो लिखा है 60 डिग्री सेंटीग्रेड वाला जो एक्सपेरिमेंट था ना दैट वाज दैट वाज द फास्टेस्ट तो वो 60 डिग्री सेंटीग्रेड वाला आई थिंक इट वाज एक्सपेरिमेंट 3 एक्चुअली so I'm going to write that down. This is experiment 3, this is experiment number 2 and this is experiment number 1. ये इस साइड पे लिखे हुए हैं ठीक है अच्छा then you have a question what's a water bath water bath है कि अच्छा water bath क्या होता है water bath होता है कि it's a method of indirect heating ठीक है for example if I want to heat the conical flask ठीक है here's my conical flask and here are all the reactants in it I'm going to put it if I want to gently but a direct heat करेंगे ना Bunsen burner so what's going to happen is कि the heating would be very uneven तो ठीक है so that's what you do कि for even heating and इतनी वेरिएशन ना हो हीटिंग के अंदर यू यूज अ वाटर बाथ और वाटर बाथ का टेम्परेचर कंट्रोल करना भी आसान होता है क्योंकि यू कैन पुट अ थर्मोमीटर विद वाटर का टेम्परेचर डजंट चेंज वेरी फास्ट ठीक है सो फॉर एग्जांपल इफ वाटर रीचेस 40 डिग्री सेंटीग्रेड तो वो उसमें ना इंक्रीज और डिक्रीज जो होता है ना दैट डजंट हैपन वेरी वेरी फास्ट सो water baths are good for that anyways why do the reactions stop so now here's a question why do the reactions well, why are they stopping now they're not stopping क्योंकि उसने मेरे ख्याल से start में कहा था कि calcium carbonate excess में so they're not stopping they're stopping because HCl gets used up because if you remember I think start के अंदर ना he said कि calcium carbonate is in excess which means calcium carbonate तो खत्म नहीं होने वाला HCl would get used up so the next one question number 3 carbon and copper 2 oxide are both black solids. Copper 2 oxide reacts with dilute sulfuric acid to form an aqueous solution. Uh, carbon does not react or dissolve in dilute sulfuric acid. Neither copper nor copper 2 oxide dissolve in water. Okay, so I'll just briefly break this down first. So they both, first thing, both are black solids. And he's saying copper 2 oxide reacts with sulfuric acid to form an aqueous solution. इसकी equation भी लिख सकते हैं कि copper oxide, it's a base. Metal oxides are bases. Sulfuric acid के साथ ना acid base reaction होगा. What's going to happen is कि it's going to form CuSO4 plus water molecule. ठीक है? So copper sulfate would be formed. And remember, it's a blue solution. Copper sulfate has a blue color. Or copper oxide जो था ना, that was black. So anyways, I don't think they even asked for that equation. So you have copper 2 oxide reacting with sulfuric acid to form an aqueous solution. Carbon is not reacting, obviously, and neither both of them don't dissolve. So they're both insoluble. The mixture contains carbon and copper 2 oxide only. Plan an experiment to produce a sample of pure carbon from the mixture. You may use dilute sulfuric acid, distilled water, any of the apparatus usually found, etc., etc. Know the chemicals are available or how to dissolve the copper 2 oxide in the sulfuric acid, how to separate the carbon, how to purify the carbon, observations occurring at each stage of the process. So how many marks is this. It's a 5-mark question, so you have to kind of give it a little bit of detail. And so you have copper oxide and carbon. That's the mixture. So step one, I said both of them are black solids. Okay, so both of them are black solids, and now copper oxide dissolves in sulfuric acid. So step one is add excess sulfuric acid. So add excess H2SO4 and stir vigorously. Ali, what's your question? Can you explain your question? Okay, why am I adding sulfuric acid? I said, Chathi, I'm going to talk. Charity, I'm going to talk closer to the mic. Can you hear me properly now? Acha. So, as a first thing, why am I adding sulfuric acid? Usne na start mein na. I mean, the basic idea is you have to dissolve. You have to separate copper oxide and carbon. उसने कहा है कि copper oxide जो है ना वो sulfuric acid के साथ react करता है. ठीक है, is already mentioned that. He's already told us initially कि carbon नहीं करता. Carbon does not react. Copper oxide does react. और हमें चाहिए क्या था? He wants us to extract carbon. ठीक है, so that's what the goal is. उसने सिर्फ ये information दी हुई है कि जो mixture है ना copper oxide and carbon का. Step one is if I mix it with sulfuric acid and stir it vigorously. Now he's already told you the answer is in the question. Okay, they've already given you the answer. So if you add it in sulfuric acid and stir vigorously, so what's going to happen is कि copper oxide, वही जो equation पहले लिखी थी, it's going to dissolve in sulfuric acid and it would form CuSO4 plus water. So Usman, मैं फिर से explain करूँ कि I'm going to explain this again. Used to start when he told us that there's a mixture of carbon and copper 2 oxide and they're both black solids. इन दोनों को separate करना था. ठीक है, you had to separate both of them. And he had mentioned only one thing. Only one important useful information was given in the question, which was that copper 2 oxide जो है ना, it reacts with sulfuric acid to form an aqueous solution. वो मैंने equation भी लिख दी थी कि copper oxide जो है ना वो sulfuric acid के साथ react करता है and carbon does not react or dissolve in sulfuric acid. तो अलग करना है ना, so the way you're going to do that is कि इस पूरी चीज को ना, this entire thing, just add, ठीक है, this entire thing, add sulfuric acid and stir vigorously. So what's going to happen? Copper oxide will dissolve and forms a blue solution क्योंकि this copper sulfate is a blue solution. Remember, ये ऊपर ना उसने लिखा हुआ था कि observations occurring at each stage of the process, they're also supposed to be mentioned. So I'm going to write down, so copper oxide will dissolve and forms a blue solution. तो अब आपके पास क्या पड़ा हुआ है? ठीक है, if I draw the beaker, ठीक है, if I draw the beaker, तो कार्बन जो है ना वो तो उधर का उधर ही पड़ा हुआ है. ठीक है, कार्बन is there, so the carbon is still there, and so the carbon is still there. और इसके साथ जो solid copper oxide था ना वो तो dissolve हो गया. It has formed this blue solution, so it's become part of the, it has ended up forming CuSO4, which is blue. ठीक है, so it's formed a blue solution. अब कार्बन को बाहर निकाल ले तो क्या करोगे? Simply वो dissolve हो गया. That's gone. It's part of the solution. You filtered it out. So that's what you're going to do. What you're going to do is filtration exactly. So filter the remaining solution and remove the residue. Exactly. ठीक है, exactly, it's going to be remove the residue, which is basically carbon. तो वो आपको मिल गया, ठीक है, you've gotten carbon, and that's not it. उसको wash भी कर लो क्योंकि it's an insoluble residue, उसने पहले ही कहा हुआ है, it's insoluble. So remember, whenever you have an insoluble residue, क्योंकि somewhere he said कि बड़ा प्योर किस्म का उसे चाहिए, how to purify the carbon, ठीक है, उसने कहा हुआ है ये, how would you purify the carbon, कि बीच में कुछ और तो नहीं आ गया, तो you're going to wash it. वॉश करने से कोई फर्क नहीं पड़ेगा, it's not going to get dissolved, ठीक है. So it's going to be, wash the residue with, which is carbon, with distilled water. Remember, खाली tap water या water नहीं लिखना, it's always going to be distilled water. And the last thing is dry the residue in sunlight. So you dry it in sunlight. Okay, and that's pretty much, you've given a lot of explanation, and um, although से कहा हुआ था कि chemical equations are not are required, uh, we've pretty much given all the information that is needed. Let's move to the next part of the question, which is, and I think this is a test for cations. Okay, it's a test for cations. The question is, a student is provided with three solutions. There's zinc sulfate, copper sulfate, and calcium nitrate. So all three are given over here, and the student tests three aqueous solution. नहीं, किस टाइप के, इस टाइप के नहीं, ये याद रखो कि ना नहीं, पहले बताओ कि 5070 ही कर रहे हो ना आप लोग, क्योंकि अब जो रीसेंट पेपर्स आ रहे हैं ना, द फॉर्मेट इज काइंड ऑफ चेंजिंग. ठीक है, वो पहले एक ही टाइप के क्वेश्चन होते थे, वो मुझे पता है कि इट्स ऑलवेज एग्जैक्टली द सेम टाइप. अच्छा नहीं, इनका स्टैंडर्ड तरीका, if I open अच्छा, if I open let me just hold on 1 second, let me share something with you. ठीक है, if I can I send a file? ठीक है, हाँ ठीक है, let me send you a file. uh, just 1 second, this file is going to help you a lot. Hopefully मुझे मिल जाए. Just 1 second, give me 1 second. ठीक है, desktop, let me find the file and I'm going to send it over here. uh, data sheet नहीं, this one पता नहीं, ये तो zip file चली गई. एक सेकेंड. As I'm going to open this अच्छा, इसका स्टैंडर्ड तरीका ना, there's no shortcut to, मतलब I've tried different ways, but there's no this, मतलब brute force चाहिए होती है. Just remember one thing, we can go over these tests. ठीक है, we can quickly go over these tests. Just uh, give me 1 second, I'm going to open it over here. ठीक है, वो टेस्ट याद करने का ना जो थोड़ा बहुत तरीका है. ठीक है, just hold on 1 second. So now this data sheet, this revision data sheet, this can come in So acid basis salts वाली data sheet, ठीक है? This over here. Now, if you go through these tests for a second, now there are lots of different tests, ठीक है? तो आप उनको colors की तरह ना group कर सकते हो. Uh, वैसे तो brute force है कि you have to sort of remember everyone, every test. Make sure you print them out, keep it in front of you. Picture memory बड़ी अच्छी होनी चाहिए. That's the only way you can actually remember them well. Uh, ये BR-1, I-1 in or CL-1 इनके टेस्ट बिल्कुल एक जैसे हैं, ठीक है? Look at them. It's all this. मतलब इन सारों के टेस्ट ना बिल्कुल एक जैसे हैं. It's acidified with dilute nitric acid, then add silver nitrate. But precipitates different होंगे. For CL it's white, for BR it's cream, yellow. Nitrate का टेस्ट जो है वो चलो याद रखना पड़ेगा. Sodium hydroxide, aluminum foil. Sulfates, barium nitrate डालो, white precipitate, sulfite. हाइड्रोक्लोरिक एसिड में you warm gently sulfur dioxide produce होती है जो वो ऑक्साइजिंग एजेंट को ना कलर चेंज कर देता है, पर्पल टू कलरलेस. तो some of the tests can be remembered because they are very similar. कार्बोनेट्स का एसिड डालो तो कार्बन डाइऑक्साइड गैस प्रोड्यूस होती है. And the same could be very इसमें ना कुछ जो white precipitates हैं, it's calcium, aluminium and zinc. ठीक है, इसके अलावा तो कोई नहीं है ना? नहीं. So calcium, aluminum and zinc, they all have white precipitate. Zinc के white precipitate सारे soluble होते हैं. इनके टेस्ट, cations के टेस्ट याद करना है, that's easier, relatively easy because अच्छा they're relatively easy. Why? Because एक ही टेस्ट होता है. NaOH डाल दो या फिर अमोनिया डाल दो. So it's always the same test. Now for zinc, zinc is easy to remember. Zinc is के उसके soluble होते हैं both में. Aluminium जो होता है first के अंदर soluble होता है, second में the precipitate is insoluble. Calcium का insoluble ही होता है. बल्कि दूसरे में तो precipitate नहीं बनता, slight white precipitate. Ammonia mines, I think kind of easy ammonia gas produce हो जाती है, so you can remember that. Chromium green, iron green, दोनों का approximately. Chromium और iron का जो test है that's almost the same, except कि iron के दोनों में insoluble है, chromium का one में soluble है, sodium hydroxide में it's soluble. कॉपर के ब्लू प्रेसिपिटेट बनते हैं, एक में सॉल्युबल होता है तो वो डीप ब्लू हो जाता है. एनीवेज, नो शॉर्टकट है, ठीक है? देयर इज नो शॉर्टकट है. यू हैव टू, दिस इज वेरी इंपॉर्टेंट फॉर एटीपी. You have to remember the test and then the test for gases and then some of the flame tests as well. So you have to remember all of these. तो इसको प्रिंट करके अपने सामने लगा लो और रख लो. चले ठीक है, we move on. अच्छा पहले मोल्स का क्वेश्चन कर लेते हैं, ठीक है? We'll skip this one for a second because people have been asking about moles. तो let's, किधर रह गया moles? एक सेकंड, just let me check whether this is, ये moles आ गया. अच्छा moles का करते हैं question. The question is solution J. अच्छा moles का question, when you're doing a moles question, पहले तो moles अच्छे होने चाहिए. You must know how to you must know all the formulas, whatever methods moles is. The other thing is do some sketching of what's happening because there are lots of steps in this moles question, जो titration का question है. So it's going to help you out if you just on a rough page somewhere on the side you sort of sketch what's happening. So what's happening is a student does an experiment to determine the concentration of sodium chlorate. This is the whole thing that's going to happen. J में ना sodium chlorate कोई चीज़ है and he's going to ask figure out the concentration. The 25 cm of J is added to a conical flask. Why does the student use pipette instead of a measuring cylinder? Because pipette is more accurate. Pipette is really accurate. Remember, measuring cylinder, Jonah, that's kind of not a very accurate device. It's not a very accurate device. Plus, it's well, the good thing about a measuring cylinder is that you can measure things quickly. Pipette जो होता है ना, it has a very small opening, तो उसमें drop by drop चीजें निकलती हैं, तो it's a slow device. So measuring cylinder is not accurate though. अच्छा, which other piece of apparatus could be used to measure 25 cm cube of J? तो measuring cylinder और pipette तो हो गया, तो there's only one other measurement device which is a burette. So you could not a conical flask. नहीं नहीं Qasim, conical. अच्छा, remember there's some devices that are containers. Conical flask का ना कोई काम नहीं है, measurement से कोई काम नहीं है, ठीक है? It's just a container. There's another device, beaker. ठीक है? Beaker is not a measurement device. ठीक है? तो इस तरह की चीजें ना, टेस्ट ट्यूब जो होगी, that's not a measurement device. Measure करने के लिए ना, you have mostly these three things. It's either a pipette or a measuring cylinder or a burette. एक और होता है वॉल्यूमेट्रिक फ्लास्क, लेकिन वो ऑब्वियसली वो सोल्यूशन बनाने के लिए यूज होता है, मेजरमेंट के लिए नहीं. तो सॉल्यूशंस मेजर करने के लिए ओनली दीज थ्री डिवाइसेस आर देयर, नॉट these are just containers. ठीक है? इसके अंदर बस आप रिएक्शन करते हो, या बीकर के अंदर ना कोई चीज स्टोर करनी है तो आप बस उसके अंदर यू जस्ट पुट दैट थिंग इन देयर. Now, the student adds an excess of sodium iodide and an excess of hydrochloric acid to the conical flask. A reaction occurs to form iodine. So, I'm just going to briefly explain what's happening. पहले उसने क्या डाला था बीकर में? सोडियम क्लोराइड डाला था. अच्छा, remember the reaction is not important, so I'm just writing this to explain this. सोडियम क्लोराइड डाला था फ्लास्क के अंदर. उसके बाद क्या डाला उसने? He added sodium iodide. You don't need to even know the formula. Sodium iodide, and you added hydrochloric acid. So all these three things were added into the conical flask. Remember, this is added into the conical flask, और फिर वहां से ना रिएक्शन शुरू हुआ और वो कह रहा है कि आयोडीन बन रहा है. So iodine is getting formed in the conical flask. So iodine is formed. तो अब conical flask में पड़ा हुआ क्या है? तो मैं इधर ना, इसलिए मैं कह रहा हूँ स्केच करो साथ साथ चीजें. वो जो भी था ना, वो रिएक्शन हुआ. अब conical flask में क्या पड़ा हुआ है? आयोडीन. क्योंकि he added all these things, sodium chlorate, sodium iodide, HCl, और उससे क्या है कि iodine form हो गया. तो अब conical flask contains iodine. The amount of iodine produced can be determined by titration with aqueous sodium thiosulfate with a suitable indicator. Titration का मतलब है वो अब ऊपर से ना वो डालेगा कि the amount of iodine produced in the conical flask can be determined by titration with sodium thiosulfate, जिसका formula उससे, he's already given you the formula, it's Na2S2O3. ठीक है? So I repeat, a quick recap. What's going on? What's going on is he took 25 cm cube of sodium chlorate. He put it in a flask and mixed sodium iodide, and he mixed HCl. And immediately a reaction happened and iodine is formed. तो iodine बन गई और फिर उसको ऊपर से titrate कर रहा है सोडियम थायोसल्फेट के साथ. उसका फॉर्मूला भी दे दिया उसने. Everything is given. So now the question is, he's given you the concentration of sodium thiosulfate as well, which is what is the concentration? It's given as 0.05 mole per dmq. Remember that. Okay, let me change the marker. So he's given you that. It's 0.05 mole per decimeter cube. So he's given you the concentration. And this is solution L. इसको वो L कह रहा है. ठीक है? So this is solution L. It's put into a burette and run into the conical flask. ऊपर से ना वो ये डाली जा रहा है और end point is reached. Now the question is, first question का कोई ताल्लुक नहीं है titration से. बस ऊपर से solution L डाला है और नीचे iodine में डालना शुरू कर दिया. This is the burette falling into the iodine over here. Now the first part is, why is it wrong to wash out the burette with water immediately before filling it with L? So why is it wrong to wash out the burette with water uh, immediately before filling it with L? Achha, now focus on the burette. Remember, sodium thiosulfate has this concentration. If you can see my pointer, sodium thiosulfate has this concentration. तो वाटर से क्यों नहीं वॉश करना चाहिए? Why is it bad for? क्योंकि बीच में अगर वाटर रह गया ना तो water is going to make it dilute. The water presence of water will make Na2S2O3 dilute. ठीक है? It's going to make it dilute, and that is going to mess things up. कि वो concentration ही change कर देगा. मतलब you'll be thinking it's 0.05 mole per dm cube. लेकिन if you have washed the burette with water and there's still water remaining in the burette, the water itself mix हो जाएगा and it's going to make the whole solution dilute. So the concentration would change. You'll be doing calculations using this, but the concentration might be lesser. Anyways, the next question is, okay, you're supposed to make a table. Achha, so anyone can in the chat give me the values, plus minus subtraction. That's it. That's the easy part. Now this is 3-4 marks for free, completely for free. Remember, he's adding ऊपर से ना he's adding Na2S2O3. ठीक है, and नीचे flask and then there is iodine that's present. That's what's happening. I said, so the values. The first one is final Burek reading is. I said, remember, a lot of people actually make this mistake, and that is, okay, they remember whenever you're given any apparatus and you have to take the reading, so it's always from lower to higher side. बहुत सारे लोग ना इसको जल्दी में ना they just write this is 24.6. They think it's 24.6. Remember, values have to be read from the lower side to the higher side. So this is actually 23.4. And they always have to be, for a burette, they always have to be written up to one decimal place. So it's 23.4. And the first one is 0.0. But you're not going to write 0. It has to be 0.0. As a second one, what is this? This is not 50.8. It's lower to higher करना है 49.2. The other one is ऊपर से नीचे आना है, ठीक है? Not lower value 24 से start counting, ठीक है? So it's going to be 24.8. Can anyone give me the values? The other one, that's 33.6, I think. And that is exactly 10. As a first volume of fell use, that's 23.4 in the first one. In this last one, I know it's 23.6. This one I can guess if somebody can tell me or type what is 49.2 and क्या बनेगा 92 and 48. That's what is it? Okay, this one simple math करनी पड़ेगी. This would be 8 and this is 12. This would be 4. This would be 844. You buy 4. And this is as a 24.4. Okay, so we've got the value. Best titration results are the ones that are closest to each other. These two are the best titration results. ये value थोड़ी दूर है बाकी सारों से, so उसका मतलब इसमें कोई ना कोई मसला है. Some error must have occurred. So you're not going to use that value. So you're going to use 23.4 and 23.6. And then you have to calculate the average. Show your working. Always show your working. It's going to be 23.4 plus. हमेशा working show कर देना, ठीक है? And divide by 2. So it's going to be 23.5. And now you're being asked, अब मुझे यहाँ पे पता लग गया, इधर आ जाओ, मेरा average volume titration पे ही आ जाओ. I knew the concentration जो कि पिछले step में दी हुई थी. कहाँ दी हुई थी? Somewhere over here. It was already provided. It's 0.05 mole per decimeter cube. So I'm going to go back. जो ऊपर से सोडियम thiosulfate add हो रहा था ना, I knew कि it's 0.05 mole per decimeter cube. That is already known. अब volume भी पता लग गया. कितना volume use हो रहा है? 23 point. Average volume क्या है हमारा? 23.5. So I know concentration now, and I know the average volume, which is 23.5 cm cube. तो अब वो कह रहे हैं कि मोल्स निकालो इसके, ऊपर से सोडियम थायोसल्फेट कितना ऐड किया है. तो जो अगला पार्ट है ना, that's calculate the number of moles of sodium thiosulfate in the average volume that's coming out over here. The average volume is coming out to be 23.5. The concentration is 0.05. तो moles निकालने हैं. How do you find moles? Moles का formula क्या है? Moles is concentration multiplied by volume, or any other way that you figured out. You must have some people would have found different ways of finding moles. Let me take out my calculator for a second. तो क्या value आ रही है? That's coming out to be 23.5, and I'm going to multiply it by 0.05, and it has to be divided by 1000. So 0.0011 नहीं 1.175 1000 से divide किए 0.001175. वॉल्यूम हमेशा डीएम क्यूब में होना चाहिए, ठीक है? So it's 0.01175 moles. तो ये याद रखना कि सीएम क्यूब नहीं लेना. It has to be converted into DM क्यूब डिवाइड बाय 1000 होता है, ठीक है। अच्छा खैर मुझे पता लग गया कि ऊपर से ना सोडियम थायोसल्फेट कितना ऐड हो रहा है, ठीक है। इट्स कितना ऐड हो रहा है, 0.00117 moles, that's the amount that's being added, ठीक है। ये हमें पता लग गया। अब आ जाओ नीचे। अब वो कह रहे हैं सोडियम थायोसल्फेट के मोल्स पता लग गए, 0.001175। अब उसने डेफिनेटली क्या कहना है, he's going to tell you, अच्छा, now what he's going to tell you is, अच्छा मोल्स कैसे निकाले, मोल्स इस फॉर्मूले से concentration multiplied by volume, n is equal to C into V. If मैं दोनों तरीके बता दूंगा। Remember ये titration का रिजल्ट तो आ गया ना कि how much sodium thiosulfate is being added, that's 23.5 cm cube, और सोडियम थायोसल्फेट की concentration पहले ही पता थी, ठीक है, that was also known. तो if you know volume and concentration, तो आप दोनों को मल्टीप्लाई कर दो, you'll get moles, ठीक है। n is equal to C into V, ठीक है। You can use ratios as well. There is another method of solving this, and that's ratios. लेकिन concentration into volume करो तो you'll find moles, ठीक है कासिम। तो it's 23, नहीं mass तो given ही नहीं है ना, concentration और volume given है। मतलब solutions का जो formula होता है ना, solutions का formula ये होता है, for solutions, if a solution is given, moles is concentration multiplied by volume. mass का भी बीच में कोई काम ही नहीं आया। अच्छा खैर मुझे मोल्स पता लग गए हैं सोडियम थायोसल्फेट के, ठीक है। और अगले पार्ट में ऑब्वियसली वो क्या पूछ रहे हैं कि बताओ अब नीचे वो आयोडीन में कितने मोल्स हैं, ठीक है। ठीक है, नहीं आप लोग रेशियोज यूज करते हो, रेशियो कर लो। अच्छा एनीवेज, अब वो कह रहे हैं कि आयोडीन, वो ऊपर से ना सोडियम थायोसल्फेट ऐड हो रहा था, और बॉटम के ऊपर ना देयर वाज आयोडीन, ठीक है, एट द बॉटम देयर वाज आयोडीन। तो रेशियो लगा लो कि इक्वेशन सेज कि 2 मोल्स इसके ना 1 मोल के साथ रिएक्ट करते हैं, तो व्हाट्स द रेशियो, 2 reacts with 1 iodine। तो अगर 0.001175 मोल्स होंगे इसके सोडियम थायोसल्फेट के, अकॉर्डिंग टू दिस रेशियो, व्हाट इज द मोल्स ऑफ आयोडीन, आधे हो जाएंगे, हाफ। इट वुड बी 0.001175 into x is equal to 2x, तो हाफ कर लो इसको, ठीक है। सो आई एम गोइंग टू डिवाइड दैट बाय 2, and I'm going to get 0.000587 0.000587 मोल्स। तो आयोडीन के मोल्स आ गए ये। अब अगले रिएक्शन में ना वो आयोडीन के मोल्स से उसने कहानी शुरू की है। He's saying use the equation to calculate the number of moles of NaClO। अब इक्वेशन नीचे वाली, अब इन तीनों का रिएक्शन हुआ था जो हमने शुरू में किया था, उसने अब एक is given us a fully balanced equation of, अच्छा स्टैंडर्ड और उसमें लिखने में कोई मसला नहीं है। मेरा कैलकुलेटर, मतलब कैलकुलेटर आपका जिस फॉर्म में आंसर दे रहा है ना, उसी फॉर्म में लिख दो। मतलब कोई कोई वो नहीं है, चॉइस नहीं है, मतलब आप बस कैलकुलेटर में वैल्यू एंटर करो, वो जिस शक्ल में आंसर दे रहा है ना, उसी शक्ल उसी तरह उसी को टाइप कर दो। मेरा असल में कैलकुलेटर जो है ना वो इस फॉर्म में दे रहा है, किसी और का कैलकुलेटर ना स्टैंडर्ड फॉर्म में देगा। इट डजंट रियली मैटर, ठीक है। बस वो फजूल की ना राउंडिंग ना करना, मतलब अगर कैलकुलेटर एग्जैक्ट वैल्यू दे रहे हैं ना तो बस मतलब इसको 5875 भी लिखना, ठीक है। अच्छा एनीवेज, यू हैव आयोडीन ओवर हियर। अब वो कह रहे हैं कि इसके मोल्स बताओ, तो सेम होंगे क्योंकि रेशो 1 है, एक मॉलिक्यूल से एक मॉलिक्यूल बनता है। तो इफ दिस इज 0.00000587 मोल्स, तो इसके भी मोल्स एग्जैक्टली सेम होंगे, ठीक है। तो इसमें तो कोई वर्किंग करनी नहीं थी, फ्री के मार्क्स है, ठीक है। अच्छा लास्ट पार्ट, अब मोल्स आ गए हैं, वो कह रहे हैं मैथ से एम आर निकालो। एम आर एन ए सी एल ओ की सारों को एडअप कर लो, एक एन ए तो दैट्स 23 प्लस एक सी एल है सो दैट्स 35.5, तो ये 58.5 हो गया, प्लस 16 ऐड कर लो। तो लेट्स डू दिस ऑन अ कैलकुलेटर, इट्स 58.5 and I'm going to add plus 16, so I'm going to add 16, so that's 74.5, ठीक है, that's done। एम आर पता लग गई भाई, तो अगर NaClO के मोल्स भी पता लग गए, which we have found over here, और MR भी पता लग गई है, तो mass निकालना तो कोई मसला ही नहीं होगा कि mass कैसे निकालोगे. Calculate the mass. तो फॉर्मूला क्या होता था? मोल्स इक्वल टू जो mass वाला फॉर्मूला होता था, that was mass over MR. तो mass अगर निकालनी है तो it's going to be moles multiplied by MR. The moles are given as 0.000587 multiply that by 74.5. So let's multiply it by 0.000587, and the answer I'm getting is 0.0. I'm getting 0.04376875 grams. अच्छा, अब यहाँ पे थोड़ा सा मसला होता है कि make sure you round values to three significant figures. So it's going to be 0.043 और वो 8 grams हो जाएगा, ठीक है. Make sure you type values to three significant figures. Always use that rule. अब लास्ट पार्ट ही चल रहे हैं. उसने ये कहा कि ये जो मोल्स है कितने, ये जो मास है ये कितने में, 25 cm क्यूब में, ठीक है. तो इट्स इन 25 cm क्यूब. तो ग्राम पर डीएम क्यूब में निकालो, इसकी कॉन्सेंट्रेशन निकालो. तो ग्राम पता है कितने ग्राम्स है? 0.048438 ग्राम्स. वॉल्यूम भी पता है डीएम क्यूब में. इट्स गोइंग टू बी 0.025 डीएम क्यूब. डिवाइड कर दो दोनों को, ठीक है. तो इट्स गोइंग टू बी डिवाइड दैट बाय 0.02025. एक से गलत हो गया. 0.0438, ठीक है, डिवाइड दैट बाय 0.025. तो ये आंसर आ रहा है 1.752 ग्राम पर डीएम क्यूब. और फिर मोल पर डीएम क्यूब. मोल्स तो पहले ही पता थे. वो मोल्स कितने थे? ये थे मोल्स, ठीक है. दे वर ऑलरेडी गिवन. तो वो मोल पर डीएम क्यूब, तो मोल को डिवाइड कर दो वॉल्यूम से. नहीं, ये किस तरह निकाला है? वो कह रहा था ग्राम पर डीएम क्यूब. तो मैथ्स तो हमें पता लग गई थी. उसने कहा था ग्राम पर डीएम क्यूब ना. तो ग्राम पर डीएम क्यूब का क्या मतलब है? मास ओवर वॉल्यूम, मतलब ग्राम पर डीएम क्यूब. तो इसका मतलब है मास डिवाइड बाय वॉल्यूम. तो मैंने उसकी जो मास थी उसको वॉल्यूम से डिवाइड कर दिया, ठीक है. अब वो कह रहा है मोल पर डीएम क्यूब, यानी मोल्स को डिवाइड करो वॉल्यूम से. हाँ, वो डीएम क्यूब में कन्वर्ट कर देना, क्योंकि उसने यहाँ पे ना इट वाज मेंशन्ड इट्स 25 cm क्यूब, ठीक है. अच्छा, वॉल्यूम तो मुझे अभी भी पता है 25 cm क्यूब है. डीएम क्यूब में इट्स गोइंग टू बी 0.025 डीएम क्यूब. मोल्स हमें पहले ही पता है, वो ये सर्कल किए हुए मोल्स, ठीक है, दे ऑलरेडी गिवन. सो दैट्स 0.0000875 मोल्स. इसको जरा करते हैं और आंसर निकालते हैं. सो इट्स गोइंग टू बी 0.0005875, ठीक है, इक्वल्स टू डिवाइडेड बाय 0.025. So that gives me 0.023 and 5. Yeah, that's your 14-mark question. And remember, all moles इस तरह के ATP question एक दो और भी practice कर लेना, ठीक है. So it's going to help you a lot. अच्छा, अब ना एक चीज मैं शो करूं कि what you're going to do, ठीक है. मैं थोड़ा I've gotten tired, ठीक है. I've been talking for a very long time. But my channel, ठीक है, it has a lot of ATP papers solved. So you can go over there. अच्छा, ये मैं शो कर रहा हूँ actually. You can go over to my channel. अच्छा, mega lecture, it's youtube.com/mega lecture, ठीक है. Let me open it. I'm going to explain to you how to find this, ठीक है. बस खुल जाए जल्दी से, एक सेकेंड. अच्छा, so I've gone to my channel. It's MEGALECTURE, वैसे सर्च करना आ जाएगा, ठीक है. अच्छा, इसमें ना go over here and type I think playlist के अंदर चले जाओ, ठीक है. प्लेलिस्ट के अंदर hopefully you can search the playlist. Let's type ATP ATP. तो if you type ATP, तो अब ये moles and titration के ना, there are lots of questions. Moles and titration. एक second, let me find a playlist. इधर बीच में ना कहीं ये moles and titration, ATP questions. You can moles and titration, ATP question. तो काफी ATP questions. हाँ, ये playlist. So there's a, if you search for ATP, there's going to be a playlist and it has how many videos? It has around 15 papers that are solved. तो और उसको ना एक काम करो, अगर अगर तो आपको स्लो लग रहा है तो आप उसकी प्लेबैक स्पीड इंक्रीज कर दो, ठीक है? सो आई एम गोइंग टू पोस्ट, इसको मैं खोलता हूँ, इसका मैं लिंक इधर मैं चैट के अंदर ना, आई एम गोइंग टू पोस्ट द लिंक, इसको उधर फेसबुक के ऊपर भी ना, ये आ गया। हाँ, ये सारे मोल्स के ऊपर है और ये सारे एटीपी 15 साल के मेरे ख्याल से कोई एटीपी है ना, वो जो मोल्स के क्वेश्चन है वो सॉल्व है इसमें। तो थोड़ी सी प्लेबैक स्पीड, अगर अगर तो बहुत स्लो है तो प्लेबैक स्पीड बढ़ा दो, ठीक है? इसको तो फेसबुक पे भी पोस्ट कर देना, ताकि क्योंकि क्वेश्चंस तो मैंने सारे सॉल्व किए हैं। नहीं, 2019 का तो अभी हमने किया है, 2019 नहीं है, लेकिन सारे पिछले एटीपी ना, हर टाइप का एटीपी पेपर है इसमें, ठीक है? वो जैसा ये वाटर ऑफ क्रिस्टलाइजेशन लिखा हुआ है, so this ATP paper is related to water of crystallization. So you can do that. Finding percentage purity, finding water of crystallization. हर टाइप का क्वेश्चन है इसमें, तो इससे प्रैक्टिस अच्छी हो जाएगी, ठीक है? रिमेंबर, ये क्वेश्चन बहुत इंपॉर्टेंट है, दैट्स इट्स अ बिग क्वेश्चन, इट्स अ 15-14 मार्क क्वेश्चन। और दूसरा वो है कि आप उसके सॉल्व एनालिसिस के ना उसके रटे लगाओ। तो और ये जाके ना वीडियोस देख लो, दैट शुड बी इनफ। एंड पॉइंट पे ना, आखिरी मोमेंट में ना यही हो सकता है, ठीक है? चले, इट्स गेटिंग वेरी वेरी लेट नाउ, ठीक है? आई हैव टू स्लीप। तो just remember, okay, I'll give you my WhatsApp number as well, because you obviously have other papers as well. Uh, so I'll give you my WhatsApp number as well. जब भी कोई ज़रूरत हो, ठीक है? buzz me if I have time. I can do classes, especially late night, और कोई भी टॉपिक समझना है, ठीक है? We can have some class, तो I can help you out, ठीक है? चलिए, ठीक है, okay then. Take care everyone. Best of luck with the exam. Allah Hafiz.